All right, today we are starting Chapter 9, and Chapter 9 is called Systems of Linear Equations. So we already know what a linear equation is. It's an equation that when we graph it, it looks like a line, as opposed to a quadratic equation that would look like a U or an N. So going back to last chapter, we know how to graph things that, let's see here, all right, we know how to graph things that look like y equals 2x minus 8. Using slope-intercept form, we know that we can start at negative 8. 5, 6, 7, 8. We can start at negative 8 and make a dot. And then use the slope of 2, so up 2 over 1, or up to right 1, to make new dots, and then connect those dots to make a line. We also talked about how a linear equation has an infinite amount of answers. For instance, the point here, 2 comma negative 4, if you plug that in, you would get an acceptable answer. 2 times 2 minus 8 would be negative 4. Okay, so an x of 2 and a y of negative 4 is a solution. At the same time, if you plugged in 4 comma 0, so 2 times 4 minus 8 would equal 0. That is also a solution. And these arrows on the end of each line indicate that you could get solutions forever and ever and ever without stopping. Now, a system of linear equations is when you have two equations both using the same unknown or the same variable that represents the same thing. So for instance, I could put another equation up here, y equals negative x plus 1. And using slope-intercept graphing again, I can graph that. So a y-intercept of 1 with a slope of negative 1, meaning down and right, down and right, down and right, down and right, or up and left. Up and left, I can even jump 2, up 2, left 2. That would also work. And again, I can connect those. And I have, again, an infinite amount of answers that work for the red equation. I can plug in, looks like 1 comma 0. So negative 1 plus 1 equals 0. So that's an acceptable answer. Or negative 1 comma 2. So again, negative 1, the opposite of negative 1 plus 1 would equal 2. So again, the red equation has an infinite amount of answers as well. But notice what happens at this point of intersection right here, which would be at 3 comma negative 2. That point and that point only works for both equations. Okay, so let's plug it into the blue equation. I'll do it on the bottom here. So 2 times 3 minus 8, so 6 minus 8 would equal negative 2. So it works for that. And now let me plug it in over here on in the red equation. So the opposite of 3 plus 1 will equal negative 2. So you can see this ordered pair of 3 comma negative 2 is a solution for both equations, for both linear equations. And it just turns out that it is going to be the only solution that works for both equations. So we have now solved our system of equations. Okay. In this case, we had 2 equations for our system, but you could have more. They don't all have to be linear, or none of them actually have to be linear, but to begin this chapter, we're going to start with linear just to make it simpler at first, and then we can always jump into more complicated equations. Okay, so there you go, a system of linear equations. So you might be asking yourself, well, what's the point of having a system of linear equations? What does this do for us in the real world? There's actually a lot of times where you could use linear equations in the real world. So let's just make one up here. So let's say that you are a student and you are on summer vacation. You need to make some money to buy things because your parents are saying you're getting too old to have an allowance. You have to, do your own work. But your parents want you to learn about making money and having a job. So your mom says that she can get you a job during the summer at her office for $10 an hour. Okay, so the money you make is equal to $10 times the number of hours you work. Okay, so M stands for money here and H stands for hours. So for every hour you make $10. Okay, so I'm going to set up, let's see, we don't need the left side here. Oh well. We only really need this part for that. So again, you can use slope-intercept form here. We're going to say this is hours here. Instead of X, we're going to use H. We're going to say this is M for money instead of Y. And we're going to say, well, how am I going to label this? Let's see. Let's go to 100. So 10. Let's say that every line here is going to represent 10 hours. So we got 10, 20, 30, and so on. 40, 50, 60, 70, 80, 90. So this will be like 100 over here. All right. I'll just label a couple in between, but I don't want it to get too messy. So let's just do it like that. In fact, let's just take out that 20 just to make it look a little nicer. So 10, 30, 50, 70. We got 100 over here. Now for this, let's make each line 100. So $100, $200, and so on. But let's skip just to make it neater. But enough so that people know where we're at. So 500, 700, and so on. All right, so we can graph this. Well, if the slope is 10, so the slope in this case equals 10 over 1. Now 10 over 1 is a little small for this graph because the rise being 10, that would be hard to graph since each line is worth 100. So let's make it a little bigger. So remember, we can use an equivalent fraction here. Let's use 100 over 10. That'll work fine. Since I labeled everything on the graph blue, let's make this red, and we'll make our equation red. So money equals $10 times hours. So if we work 0 hours, we make 0 money. And if we work, so the slope, the rise is money. So if we make $100, we work for 10 hours, and so on. Or if we make $200, that means we worked for 20 hours. Okay, so we're going to use our slope of 10 over 1. Now in this case, it looks like a slope of 1 over 1 based on if the labels of the axes were exactly the same. But remember, the x or the h axis is by tens, and the y or the m axis is by hundreds. Okay, so it's not actually a 1-to-1 relationship. It's actually a 10-to-1. We don't really need to extend it out down here to the left because you're never going to work negative hours. Okay, so that's that. That's a linear equation. It's pretty simple. If I work 30 hours, I'm going to make $300. If I work 50 hours, I'm going to make $500. Yeah, might be off just a tad, but that's pretty much where we're at. So I'm going to end the video here, and then in the second video, I'm going to add a new equation to it. And we'll see how we can make this a linear relationship, or a linear system relationship.